Okay, and so now we're on to our final core research project for today, although keep in mind we have a great keynote talk coming up after lunch as well, so please stick around. But this is for the core research project, Designing AI to Advance Racial Equity. So first we're going to have Angela Haddad of the Department of Civil, Architectural, and Environmental Engineering to present Improving Pedestrian Safety, a study of vehicle-pedestrian interactions using videography and virtual reality. And then Whitney Nelson of the School of Information, who will share LLMs for community engagement, enhancing community engagement for UAM planning.
So, we are part of the group for the co-research group for designing AI to advance racial equity. And just to give you, I'm very short, and this was not designed for me, but just some context about why we were pursuing this research. And part of transportation, we are always concerned about making sure that the systems we design allow all transportation system users, aka us, to navigate between our origins and destinations safely and efficiently, and safety is a very important aspect of all of this. Unfortunately, we have not been doing a very good job. Pedestrian crashes have been through the roof. Each year, we have a record-breaking number of pedestrian fatalities, specifically on our road. We had over 7,000 fatalities in 2022. And when we look more into these fatalities, we see that they're not equitably distributed across all groups. And specifically, we find certain sociodemographic groups are overrepresented in the pool of fatalities and pedestrian crashes in general. And for example, Black pedestrians have double the risk of being involved in a fatal pedestrian crash compared to other pedestrians from other races. And most of the research that either we have done or others have done in this space have attributed these overrepresentations due to factors like infrastructure or built environment or higher use of walking and public transit, making certain groups more exposed to being involved in pedestrian crashes. But we were those annoying researchers and went in there and actually found out that even when we accounted for all of this, it wasn't enough to explain the overrepresentation. And there's about a 6 to 7% amount of this overrepresentation that cannot be accounted for just by looking at the environment. And this made us want to think about drivers' behaviors and pedestrians' behaviors and how pedestrians and drivers interact on those few seconds on the street before a crash happens or doesn't happen. And this is what we're doing here. So our core question is, how can we document, understand, and address racial disparities in pedestrian safety? And we do that over two phases. The first one is related to using video data to actually monitor pedestrian behaviors and decisions. And we actually monitored 2 locations in Austin for 1 month each and collected over 1,300 hours of video that we actually manually reviewed in-house. That was equivalent to over 20,000 pedestrians that we looked at their behavior on the streets and over 3,000 pedestrian vehicle interactions. And so as I said, we collected 2 locations in Austin. One is actually very nearby to where we are, is the East Dean Keaton San Jacinto intersection, and the other intersection is more up north near the Domain area. And we got this video data, and we had a very big group of students who did the great job of looking and processing all this video. And each time they see a pedestrian, they were asked to report their perceived age, their perceived skin tone, other appearance and behavior characteristics. For example, for appearance, we also wanted to know if the person is exhibiting some visual cues of experiencing housing instability. Like, are they carrying all their belongings with them? Are they holding a sign or pushing a metal cart of some kind? And we wanted to note all these as well because there is some data showing that unhoused people are also more likely to be involved in such crashes, and we wanted to look into that further. And for each pedestrian, we looked whether they actually committed a violation or jaywalking, whether they crossed when the walk sign was not on, or they crossed outside the crosswalk. And when there was a pedestrian vehicle interaction, we wanted to note if the vehicle actually yielded to the pedestrian or not. assuming that the vehicle was supposed to yield to the pedestrian in that interaction. And after we labeled all this data, we were able to do some cool modeling and statistics stuff to identify important patterns. First of all, over 8% of the 20,000 pedestrians actually jaywalked in our data set, which is not negligible. And we were, by doing certain logistic models, we were able to identify certain patterns of who are the jaywalkers or who is more likely to jaywalk and when. And for example, the first one is unkempt appearance, and it's showing that if someone was untidy, might be perceived as unhoused by a driver or by us in this case, they had a 3.58. They were 3.5 times more likely to jaywalk compared to other pedestrians. So that was an important behavioral aspect on the pedestrian side. But we also found that time also plays a role. For example, pedestrians were more likely to jaywalk at night or dawn when there were no other cars. Runners were also more likely to jaywalk, and there was a running joke for us when we were labeling the data. If there's a male runner who was running topless, they are going to jaywalk. We did not need a model for that. Morning and evening, when people were time pressured, they were more likely to jaywalk. They wanted to get to their jobs on time. Looking at the pedestrians' socio-demographic factors, we found that men are 1.5 times more likely to jaywalk, and people that were black were 1.4 times more likely to jaywalk. And finally, we had, if you were crossing with a group, you're less likely to jaywalk whether the person was alone on the intersection. And why is this important here and why is it important in the discussion of AI is that we want to make sure that we are not encoding this existing bias into AI. If I just use this data from the labeled data from the videos we just collected and decided I want to train a computer vision system to predict jaywalking, it might over-predict jaywalking for certain groups and under-predict it for others, just because the data showed us that from these two intersections in Austin in May and June of 2024, for example. So we want to be more mindful that our AI systems, when we're training them, they are not just picking up on these correlations without trying to understand what are the behavioral drivers that are causing people to behave in certain ways. And then if the city of Austin decided to add a camera on an intersection for enforcement reasons and wanted to detect for jaywalkers, some groups may be more detected than others versus other groups will not be detected. And this is something that's really important and just makes us want to think further about how do we test our models for these kinds of biases and make sure we have accurate representation and accurate prediction for all groups, regardless of their socio-demographics. And on the yielding side of things, so how cars behaved when they interacted with a pedestrian, cars were also less likely to yield if they found that the person might look unhoused or they perceive them as unhoused. And there's like a 3.4 times higher likelihood of a car not yielding to such people. And same for age. Cars were less likely to yield for people who were black, to men. In the morning, maybe they rush to get to work. Again, if we're trying to model the AI navigation systems for autonomous vehicles to yield based on observed driver behavior data, well, drivers are biased. And, well, 13.6% of our drivers did not yield when they should have. And we also need to make sure that this encoding, we are addressing this encoding existing bias into our AI models, especially computer vision that's based on video. However, this provides a great opportunity here because, especially for yielding, it's based on driver behavior. Drivers are unconsciously making split-second decisions when they're interacting with pedestrians. And if we do, in fact, take that out of the equation, we will definitely improve safety for pedestrians. And that brings us back to the big debate that was had here yesterday, whether autonomous vehicles are, in fact, improving safety or not. And I think based on our findings, it can go either way. And just quickly, after we did that, we wanted to go more into the head of pedestrians and try to understand how they're making these decisions, especially the dangerous and risky ones. So our next step is to do a VR study or virtual reality simulation where we will ask pedestrians to cross in a virtual environment, and we will subject them to different variables, where the location they're dropped in the virtual environment, the time pressure, traffic levels, whether there are other people jaywalking or not, and see if there's a social influence. And hoping by measuring how people make choices, whether to jaywalk or not, the time they take to make a decision, and their speed and other behavioral factors, we're able to understand the why factor behind the crossing decision and try to have a better perspective about jaywalking and yielding. And hopefully this will help inform AI systems to be trained with more behavioral to understand these behavioral motivations rather than just absorbing demographic correlations without the dynamics behind them. And I think next I will introduce my colleague Whitney, who will talk about urban air mobility.
Yes. Thank you, Angela. That was great. Hi, everybody. I'm Whitney. I'm a first-year PhD student at the School of Information. And today I'm going to be talking about LLMs for community engagement, enhancing community engagement for UAM planning. Just want to quickly note that I'm part of the Human AI Interaction Lab situated at the iSchool. I'm advised by Dr. Min Kyung Lee. And that this work could not have been done without extensive collaboration with other researchers here at UT, including Chandra, who's Angela's advisor, Dale, who's another PhD student at the engineering school, and then also an external team making up researchers at UC Irvine as well as Iowa State. So for today, I'm going to talk about three things as quickly as possible. First, community engagement. What is it? What does a typical framework look like? Where do we think LLMs can enhance and add value to the community engagement process? And then finally, talking about our context in urban air mobility, UAM planning. So what is community engagement? So community engagement is a collaborative effort where a group who share usually a geographic proximity or a special interest form partnerships and coalitions in order to mobilize resources and influence systems with the goal of changing policies, programs, and practices. So in terms of we're thinking about the process of community engagement, it typically starts with identifying a public issue. So maybe the city, in collaboration with an advocacy group, decides we need to add bus stops. So we've identified the public issue. The second stage will be, okay, what is the goal and the objective of community engagement? And that might be, we want to know where the communities want to add bus stops. So then after you've identified the objectives, you need to identify stakeholders. Who are you actually going to engage? Who are you going to talk to? And in this example, that could be current bus riders, people who already ride the bus. That could be transportation experts. And maybe there's a target neighborhood or area, maybe East Austin, where you've decided, hey, we want to add bus stops here, but we're not necessarily certain exactly which streets, et cetera. After you've talked to the stakeholders or identified the stakeholders, you need to decide how you're going to engage them. What actually is going to be the activities? Are you going to do a survey? Are you going to try and do focus groups? Is this going to be a one-off interaction? Or do you want to engage folks in a more ongoing kind of council style? And then last but not least, analyze and report. You need a way to actually synthesize the feedback that you get, and then ideally share it back. So how are you going to share back what decisions, how that feedback is implemented or not implemented? I do want to call it, this is very linear and simple. It probably, and I know it never works this way. It's lots of circles, it goes back and forth, but just for the sake of today, this is our kind of simplified framework. So now the question, where does an LLM fit? There's three areas that we see an LLM providing value and enhancing community engagement. So first is helping to identify the public issue. The second is actually doing the engagement activities. And the third is analyzing and reporting. For today, I'll be focusing mostly on the engagement activities piece, as that's where our research is currently at. And then why even use an LLM? Why would we even consider using this type of tool? There's two reasons, and I think there's more, but these are the ones that really, I think, stick out. The first is that providing feedback puts a lot of burden on communities. They need to travel, maybe they need to take off work or make other arrangements to participate, and it's it's just a lot in terms of being able to actually provide that meaningful feedback on communities. So we think an LLM can help reduce that burden. Second is that it's challenging to scale in-depth and meaningful engagement with communities. Running focus groups, having ongoing conversation, that takes a lot of time and effort that cities sometimes or other organizations just don't have the resources in order to accomplish. So this brings us to that broad question, how can LLMs increase public participation and community engagement? So in this instance, if the engagement activity is focus groups, we envision an LLM helping to scale that moderation, maybe even providing translation services. Maybe you want to engage a group that doesn't speak English or English is their second language. And then what we'll talk about today is informing and educating on an issue. So what is our context? So our context today is urban air mobility. And if this sounds like the Jetsons, it's because it kind of is. Urban air mobility is essentially a goal to leverage the sky within urban and suburban areas for the delivery of cargo, more efficient delivery of emergency and medical services, and then actually moving people as in like metros or taxis. And you might be asking, why is it important that the community engages on urban air mobility? The design of transportation systems have a long-lasting and often discriminatory effects that can reinforce existing socioeconomic inequality. And I think locally we can just point to I-35 and see east of 35 versus west of 35. And I just put this, I really wasn't sure what I would get, but I put this into Google Maps, and every hospital except one that is very far north is west of 35. So I think this is a pretty tangible example. And then what, in terms of like engaging the community regarding UAM, it's important because we want to enhance community acceptance. Like if you're a city or an institution and you're going out and actually introducing this technology, you really want the community to accept it. You want to understand their concerns around safety. You want to understand what the noise impact might be, where vertiports, which is essentially where they're going to take off and land, how the community feels about that, as well as cost and planning and implementation of operations. And then last, why community engagement for UAM is this is actually happening a lot sooner than we think. So Dallas, for the 2026 World Cup, they're hosting several of the games, and they're actually considering using UAM technology to help move people regarding the influx. They're just going to have a ton of people come for the World Cup, and they need to move people around. So this is something a technology that does exist and that groups are actually looking at actively implementing. So our question regarding UAM and LLMs is, how can we use LLMs to inform, consult, and partner with communities to understand UAM design preferences and constraints? And we're using Sherry Arnstein's ladder of participation as a framework with the goal of using an LLM to help increase community role in public participation. So going from just informing a community like, hey, here's the UAM design, like this is what's going to happen, we've told you about it, to actually actively partnering with them on designing this transportation technology. So in terms of the demo, I'm going to show two things. As my colleague Brad emphasized before, this is definitely a work in progress. This is a first pass at things, but I'm excited to show kind of what we've got so far. The first is a UAM LLM, which is an educational prototype with the goal of informing. And then the second is a website or prototype that we built to try and understand noise fairness and noise threshold regarding UAM. And I want to talk a little bit about how we think implementing an LLM in this study could actually generate more meaningful feedback. Okay, so here's the UAM LLM. It can answer questions and describe UAM technology, use cases, and goals. Right now, it's really actively working at helping to inform. But in the future, we really want to be able to incorporate it throughout the community engagement process, as well as answer key questions related to UAM design. This is a big block of text. It's not the best interface. This is something that we would like to move forward and have it be more conversational, maybe easier to access for somebody who's not like going to sit and read all of that. Okay. And then the next thing I want to show is the study that we've developed related to noise distribution and threshold. The way it is, designed right now is it's very static. We've got images and things like that to help illustrate UAM, but it's not really bringing it to light. It can be difficult, I think, for anybody to envision a technology that doesn't exist. So we anticipate or are hopeful that an LLM can help bring this type of technology, make it more realistic and tangible. And then the other thing is make these scenarios a lot more dynamic, because they're pretty static right now. It's representing one instance, and if we can make these scenarios more dynamic, more interactive, I think we can get a lot more meaningful feedback. So in terms of other future directions we're considering with LLMs and community engagement, I've talked a lot about the scale and scaling mediation, so doing more focus groups, providing those resources to cities and other institutions. We're also thinking about speculative futures. How can groups co-create collectively a UAM future utilizing an LLM? So that's my talk for today. If you want to share your UAM concerns, please feel free to scan this QR code, fill out a brief survey. It would be super helpful. Or you can always just shoot me an email. Thank you.
Hi, thank you so much. Y'all both had fantastic presentations. I had a question for Angela. I was wondering if you did any sort of collection of demographic information of drivers. I'm curious to see if the yielding patterns of drivers was across race or other factors for the drivers as well as pedestrians.
Unfortunately, we could not see inside the cars from the cameras that we had positioned. We actually had the camera was quite far away. We had one at the ECJ building at one of our offices, and we were just snooping, which is legal. But just to be clear. With this kind of zoom, we were able to see the pedestrian clearly, but it was hard to see inside the car, unfortunately. And I think that would be a very important aspect. The only thing we could tell was if it was a luxury vehicle or it was a truck or a sedan and SUV, based on descriptive statistics, pickup trucks were less likely to yield. However, it did not turn out to be a statistically significant factor when we did the logistic models. So take it or leave it, I guess. There is some indication, but we don't have concrete evidence at the moment.
Thank you so much.
Hi, thanks for the great presentations. And I have a question, I guess, more for Whitney, which is that a lot of various literature says that one of the biggest problems with community development is that efforts are siloed. So I'm wondering if there's any way that your work can leak out into the other silos.
Yeah, I think, I talked a little bit about scale. I know that's a buzzword, but I feel like being able to use an LLM or other types of technology to engage different groups and then also communicate that out in a way that's effective, I feel like that could help address some of the silos. I don't know, am I answering your question?
Not really.
Not sure.
It's more like what could you do to affect other silos? We in research we're always saying, we hope somebody's going to read our paper and implement something. But is there anything that you can do that will affect other silos?
Maybe, I'm not sure, I guess, going to more, I think maybe a more generalized framework that could come out of this because all of this is communication at the end of the day, right? How do you actively communicate with people? How do you hear them? How do you communicate back in a way that is meaningful and takes their concerns into consideration? So I think there's probably ways that we can learn from, like what we learned from just even doing this process, then could be applied across other silos, I guess.
Yeah, okay, thanks.
Mm-hmm.